everyone, today we will learn probability for grade 8. For this video we will also use CODAP. Now let's start. Now you see a caricature, and for this caricature I just want you to read this caricature and write your comments about whether duck is lucky or cat is lucky on comment box, and please explain why you are thinking like that. Now let's look at the warm-up question. The warm-up question says car has 18 marbles with same model but different colors. 3 marbles are red, 5 marbles are yellow, and 10 marbles are blue. Car thinks that if she drops 1 marble from the box, which one will be drawn? Can you help Car? Which one has the most chance to be drawn? And which one has less chance to be drawn? Please stop the video and try to solve this question by yourself. Then we will solve this question together. What we have? Yes, we have yellow marbles, blue marbles, and red marbles. And what can we say about the quantity of these marbles? Yes, we can say that the number of blue marbles are more than number of other two colors. And what about red ones? Yes, the red marbles are the ones which are less in the box. So if we think about the chances of these marbles to be drawn, we can say blue marbles have most chance to be drawn because they are more in the box. So what can we say about the red ones? Yes, the red marbles have least chance to be drawn because they are less in the box. Yes, you solved the question. Congratulations. So, what generalization can we make? Yes, in order to decide whether the chance that an event happen less than or more than other event, we look at their number of favorable outcomes in the situation. It's just like that. This question, let's toss a coin, but this coin is fair coin. I just want you to think about getting head and tail when we toss a coin. They have equal chances or one has more chance? Please think about that. So, if you think about that, let's continue with CODAP. Let's open CODAP and flip a coin many times in order to solve our question. In order to find whether getting head and tail have equal chances when we tossed a fair coin or not, we will use this CODAP. For the CODAP, in the CODAP we have a spinner which collects data and randomly, and let's start with 5 samples it collects. For the first one it said head, and for the second it said tail. And when we collect 5 samples, let's look at its percentages. It seems that getting tail have 60 percentages while getting head 40 percentages, and maybe we can say tail has more chance. I think we cannot say. Let's look at the other samples. For this one, I wrote 10 samples. Let's collect 10 samples. It collected 10 samples as you see, and it seems that for this one, the head getting head has more chance, which is 70 percentage, and the tail has 30 percentages. I think the things get so confused. I think your mind is blowing. Let's look at the other one with 100 samples.
it collecting, and let's look at its percentages. Wow! For this one, I think getting the chance of getting head and tail so close to each other, and which is one has 52 percentages while the other one has 48 percentages. I think when we increase the samples, something changes. I will ask you to. And for this one, I collected 300 samples. And when I look at its percentages, I get this data. The head has 50% and the tail has 50%. Wow! And what do you see? Yes, getting head and getting tail at the end of has equal chances. Let's look at.
Now you watch our code part. So I want you to think about what did you realize when we increase the sample size and what inferences can we make? Please now stop the video and think 5 seconds, think about that. Now let's look at together. I agree with you. When we increase the sample size, it closes us to the actual probability. What else? Yes. Also, when you toss a coin, even you may get 5 tail and 0 head, actually both sides have equal chance. This is only the time that you are unlucky. So, what inferences can we make? Yes, the chance that the event will happen equals to its probability. So, we can say that the probability is just a word that seems more mathematical. For this question, let's roll a die for Aybüke. In this question, Aybüke rolls a dice in order to find the probability of getting 2. And what is the result that she found? Now, please stop the video and try to solve this question by yourself. Now, let's solve it together. As we know, a die has 6 sides, and which are 1, 2, 3, 4, 5, and 6. And we are talking about getting 2. As we know in our previous lessons, sample space includes all possible outcomes, and we have 6 possible outcomes, which includes 1, 2, 3, 4, 5, and 6. Now we are talking about outcome of the event, which is getting 2, so which includes only 2. If we think about its probability, which is 1 out of 6, so we can write it like 1 over 6. So the probability of getting 2 is equal to 1 over 6. Let's look at the what if part. What about other numbers on the dice? What is the chance of getting 4, 6, or 3? Let's look at. Our sample space is the same for 4 or 6 or 3. So it will like that. This is same. If we are talking about getting 3, but our outcome of the event will be only 3. If we are talking about only the getting 4, outcome of the event will include only 4. And if we are talking about the 6, getting 6, so what will be outcome? Yes, it will be 6. So, as you see, the probability of these numbers on the dice, which can be 1, which can be 2, or what else, they have equal probabilities. So, what can we say to Aybüke? Yes, we can say that all sides of a die has equal likely chance or equal probabilities when we roll it. So the probability of getting one side is equal to 1 over 6. What did you realize when you think about our questions? Yes, let's look at. While we are calculating the probability value of an event, we write number of all possibilities in the denominator and number of outcome of the event in the numerator. So if we write it in like fraction form, number of outcomes of the event over all possible outcomes. Now let's continue with new question. For this question, let's head to Ayşe. In a school, Ayşe, who is head of mathematics department, decides to choose one student for a math challenge and one for science challenge. However, she says one student for math challenge will be chosen among the students with blonde hair and one student will be chosen among the students with brown hair. What are you thinking about the chances of being chosen for the students below? Now, please stop the video and try to make inferences about the chances of being chosen for these challenges and try to give advice for Ayşe. Let's solve together. The students for math challenge has, yes, blonde hair. And the students for science challenge have, yes, brown hair. What can we say about the probability of being chosen for math challenge? Yes, there are 10 students and one will be chosen from there. So all students have the chance of, yes, 1 over 10. Let's talk about the students for science challenge. In here, we have 6 students and one will be chosen for science challenge. So all students here have the chance of, and which is probability, is 1 over 6. Let's talk about these fractions. We know that 1 over 10 is less than 1 over 6. So the probability of 1 over 10 means less than 1 over 6. Let's talk about that. Ayşe, the probability of being chosen for math challenge is lower than for science challenge. So you should think about your criteria and we give you an advice for changing your criteria for that. Let's look at the given problem. In this problem, we have a word which is probability. Mete writes each letter of this word on balls. He puts the balls on a pocket and draws balls from there. Help the Mete to find which letters have equal probabilities and which one have unequal chance of being drawn. For this one, please now stop the video and try to solve this question by yourself. Then we will solve together.
As you know, in order to calculate the probability of an event, we should write it like that. Number of favorable outcomes of the event over all possible outcomes. Let's go back our question. In our question, there is a word which is, yes, probability. And Mete writes each letter of this word on both. And he draws both from there. So, in order to help the Mete, we should think about the letters which are written. If we think about, we can say that the letters which are written in one time or which are not repeated are, yes, they are P, R, O, A, L, T, and Y. Also, there are some letters which are repeated, and also they are repeated in 2 times. So if we look at this word, we can say that they are the letter I and the letter B. So let's think about their probabilities. For each word which are not repeated, we can say that there is one favorable outcome. For example, for L, there is only L. For T, there is only T. And all possible outcomes when we think about this word, which is 11. So, for not repeated ones, the probability will be 1 over 11. Let's go back to letters which are repeated. For these letters, as you see I and B, we should think about like they are repeated in 2 times, so they have 2 favorable outcomes. So we should write their probability like 2 over 11. And also the letter B have probability which is 2 over 11. So if we think about that, we can say that the letters I and the letters B have equal probabilities, and also the letters which are P, R, O, A, L, T, Y have equal probabilities. But for example, T and B do not have equal chance, because B have more chance of being drawn. Yes, I think that you get it. Let's make a summary of what we learned. We learned that the chance of an event means probability of an event. And we also learned that probability of an event equals to number of favorable outcomes of the event over all possible outcomes. It's just like that. Now, your homework is here. As a homework, on this drive folder, there are 2 problems which are waiting for you. Please solve the questions and upload your work there. I will put the solution videos after all of you finish. Thank you so much for watching this video.